So I'm Patrick. Ralph was not able to make it, so we replaced it by a small bot. Yeah.
Sorry, it's only the reverse, no?
No worries.
Sorry about that.
No worries. So I am Patrick Mkhael. I am the team lead of the R&D part in the offensive team, also in Swiss Post Cybersecurity Luxembourg. I worked in the blue team and also in the red team, so I was able to have both view of the story from defenders and from the attacker's point of view. So today we'll be talking about the purple team with AI and bots. So first we'll be presenting the classical purple team, the old school one, and then we will talk about the automated AI-driven method, and then we'll see the real workflow and the magic, how the magic is happening. And finally, we'll have a small conclusion and what's the next step that we're gonna do. And the last part would be the question and the answer. So the old school classic purple teaming mainly has 3 teams, like the cyber threat intelligence team that's gonna collect the TTPs, the technique, tactic, and the procedures that gonna be used during the purple team based on the APT, usually APT team that's gonna target the client. Then the red team will get those feeds from the cyber threat intelligence team and will perform his attacks. And then the blue team will check the detection that occurs post attack. So first, we're going to collect the adversary technique. It's going to be fed again, as we said, to the red team, who's going to create the cyber kill chain based on those attacks. The blue team, in parallel, will try to check the detection of those attacks in terms of alert and in terms of logging. And then finally, we will have a report about the full chain and the detection success ratio. So this is a glimpse into what we tried to create. We will show it more in details during the presentation. So this is the front end. We're going to fill the information and execute the purple team exercise. Now, we're going to switch for the automated AI-driven methodology, not the classical one. So what we tried to do, the first step was to understand the human logic of the purple team. So how the red team and how the blue team are thinking and what they are going to do. The next step was to translate this logic into a structural automated steps. And the third step was to integrate the AI to enhance and to enrich this flow. And the last part was the Lego part, where we're going to combine all the steps, the previous steps, to create the automation, the AI automated bot. What we tried in what we used in this proof of concept was N8N for the automation and for the workflow. We used the Elasticsearch for the log collection, the Hive for the CM case management, Caldera to automate the adversary emulation and the attacks. We used some autonomous decision making with the if-else logic. We use WinLogB to collect the logs from the Windows machine. We had to parse the data with JavaScript. In the case of the proof of concept, we use DeepSeek and OpenAI to play the role of the AI. We had to merge the data between attacks and defense to compare it, and we used LS Alert in terms of alerting engine for the alerting part for the CM. So this is the high-level workflow. First, we're going to execute the purple team from the front-end part, the GUI part that you saw. The second step would be to deploy the Caldera agent on the target or the victim machine. The next step would be the LLM that's going to process the data that was injected from the front end. Then it will prepare, based on this input, the APT profile that we're going to execute on the victim machine. And then it's going to push and execute the APT profile on Caldera. So this part is the red team and the threat intelligence work. After we're going to execute the APT profile, the work of the LLM is now to analyze what was executed before to check the alerts and the logs on the CM and on the CM use case alerting engine to finalize it by the report. So this was the high level. Now we'll go into details of each step, what's happening in the backend. So now we're gonna see the Now we're gonna see the front end. So this is the front end where you're gonna need to put the victim IP, the domain in case you had Active Directory, the username gonna be used to authenticate and deploy the Caldera agent on the victim machine, the credentials to authenticate, the host name, and the operation name that you're gonna use for your test. Now the next step after you fill those is to select the APT profile that you're gonna execute. So here is a list of a predefined APT profile that you can create in Caldera. In case you don't want to use a predefined APT profile, you can click on AI profiling where you can put the company industry, the company location, and the company size. And based on those three values, the AI will suggest for you the appropriate APT profile that's gonna be used to execute the attack. While executing after launching the simulation, you will see here a progress about the status of the purple team exercise. You can see the logged event, the generated, the detection event. So here you can see already the ratio of the work. And here you fill the IP of the servers. And here you can see the status of each component of the purple team. Okay. So the first step, again, we filled the needed information on the front end and we submitted. So now the data are in N8N. Once received by N8N, the first step before even analyzing the APT profile or whatever it is to check if the Caldera agent is live on the victim machine. If it's already alive, the victim, an agent exists on the victim machine or the target machine, the flow will continue. Else, it will go and try to deploy the agent again on the victim machine, and then it will continue. So this is the first step, is the Caldera agent deployment. The second step would be to generate and execute the APT profile, so the technique and the tactic and the procedure that you're going to use in your purple team exercise. So here you have two choices. The first choice is to use a pre-selected APT profiles that we saw in the front end, like from the drop menu. In case you have chosen the first option, you selected the APT profile, so Caldera now will create and execute the needed operation or the pre-configured operation and abilities inside this profile. If you choose to use AI to select for you the needed APT profile, now we'll go on another flow. The first would be that those data will be sent to AI, the AI will analyze it and will suggest for you an APT profile. Now it could suggest for you an APT profile that already exists in the predefined list that you have here. In that case, it already exists, nothing needed to be created. It will execute, create the operation and execute it. If the APT profile suggested does not exist, it's something new, you don't have it in your database, then it will create, it will select the technique and tactic that's gonna be used, and it will create this APT profile, it will push it to Caldera, and then the last step would be to execute it on Caldera. Now the Caldera executed this APT profile on the victim machine or on the machine. The next step would be to collect all the executed technique, tactic, and procedure that were done by Caldera. This is the first data that's gonna be used as the first input. The second input would be all the alerts that were generated in the same time frame of the exercise on the victim machine. Both data will be merged, so input 1, input 2 will be merged, and the AI will analyze those data and do the differential to be able to know, is this technique that were done, was it detected or not? If it was detected, it will go to this pipeline where it will be sent to the last processing node. So we will forget about it a bit. If this technique that was executed, we don't have any trace that it was detected, it will be sent to the LLM, another LLM node. Now, this LLM node has all the techniques or the attacks that were not detected. But here we have to check if the logs exist in the SIEM, but a use case does not exist for them. So the AI, based on the executed technique, will generate Elasticsearch query and gonna search in the SIEM to be able to know if this executed attack is logged or not. If the executed attack has already logs in the SIEM but no use case, it will suggest a sigma rule based on the attack that was not detected. Now, the second option is that there is no trace of logs for the attack that was executed. What will happen here is that the AI will generate or will suggest a configuration change in your audit policy, either in Sysmon, either in the Active Directory GPO audit policy, to be able to have those logs the next time you do the exercise. And here there is always another possibility, is that maybe you don't have a use case also for this attack that got executed. So here the AI also will analyze the list of use cases that you have in your detection playbook or detection repo, and will also suggest for you a use case in case it does not exist. So now the final processing node will have three types of data. It will have the data of the non-detected but logged data, non-detected and not logged attacks, and you have the detected and logged attack. So those three gonna get merged, and they're gonna be sent to the HTML LLM node that's gonna be create for us a report about all that was done. So this is here an example of what a report could look on from the proof of concept that we did. So here we executed 6 techniques. The detection ratio was 33%. The logging rate was on 100%, so everything was logged. Here you will have a small summary about the APT that was chosen during the purple team. And here you will have the logic, or this, it's not the Sigma format, but the logic of the use case that you can create for the undetected techniques. And at the end, you can also find some security recommendation based on the exercise on what you can enhance in terms of detection or even prevention, like implementing LSAS if you were able to do LSAS dump, app locker policy because you were able to execute the non-signed executable, or so here some security recommendation based on the whole exercise that was done. So what's next after this proof of concept that is continuously being modified and enhanced? So we were thinking about creating an MCP server to be able to communicate easily with Caldera and with Elasticsearch. Elasticsearch already exists an MCP server, but Caldera not. So we try to create something to make it more fun to communicate with Elastic and Caldera, like search for me the last alert, give me the last execution that you saw on this machine or on the victim. Or on Caldera side, also give me all the techniques or the tactique that I have in my database based on this APT. We're going to try to deploy and train a local LLM because currently, as I said, we are using OpenAI and DeepSeek. So we're going to create a local one, feed it with Mutter attack, forensic report, our knowledge, our database that we currently have. And the last step, we try to add another source log, because currently we are only working with Windows logs, security and the Sysmon and other, but all Windows logs. We try to add EDR, IPS, IDS to try even to detect or to find when EDR also prevent an attack. So it's detection, but we have also the vector of prevention, which It's also interesting to see the prevention ratio. Also to detect IPS and IDS to see if you see lateral movements or if we're gonna do such type of attacks to see how in what logic we're gonna integrate it. Thank you. So now if you have some questions.
Thank you. Great presentation. I saw that you're output in Sigma. Beyond Sigma, what do you have of plans? What are you going to translate into, and how are you going to handle cross-correlation?
Sorry, I was not able to hear. Really sorry.
Sorry. So you're going into Sigma.
Yes.
In your output. What are your plans beyond Sigma in regards to translation into seams? And how do you intend to handle cross-correlation in Sigma?
What we can do in the future is that we can create the Sigma, we can push it as a test, to be able to see if there is a lot of false positive that gonna match on this detection. If not, we can also automate the deployment of the use case directly. It's feasible, but we need to check the ratio of the false positive comparing to how much noise it's gonna match, it's gonna create once we test it. But it's feasible to create a pipeline also to send it to LS alert that we're gonna have, so we can use some converter, Sigma converter, that's gonna convert from Sigma to Elastic or Elasticsearch format. And then we can push it and we can test it in testing mode before deploying it in production. Thank you.
Hi. Okay, my turn then. I would also have a question for you. I'm here in the back, by the way.
Sorry. Okay.
What's the quality of what is generated by the AI? And specifically, did you make it generate the code of your tests? Meaning, did it generate what was run on your VM, the test VM? Or did you just take the tests that were already in Caldera and run those ones?
What we did is that we used the abilities that exist already in Caldera as a starting point. We did not create new abilities, but I think Caldera contains like 1,300 by default abilities, so techniques. So what we did is that we made the machine learning select based on the APT profile from the database of techniques that we already have in the Caldera. So we did not force it to create a new techniques that we don't know. So that's what we tried to do.
Okay, and what about the quality of these suggestions? Because here the detection rules that were proposed were Sysmon ID1, so basically process command line creation.
Yes.
Honestly, that's not best detections I would think of.
Okay. So for the it's not only based on execution. You have event code 1 for Sysmon, event code 3 for the network. You have some DLL for event code 7. You have the security logs, the authentication for the brute force, for the lateral movement. It's not only based on execution because it's not the best thing to test. But, to be honest, it's a big part, the execution itself, in terms of execution, but for detection, we work on the behavior that's gonna be generated from this execution more than the command itself in terms of command argument that are passed. So if there is a technique that gonna dump the LSAS, we will not check the execution itself. We will see the event code 10 that something touched the LSAS. So we are working on this approach more than one-to-one execution. So really the behavior itself. And for that, what we did is that we created multiple types of machine learning agent, let's say with AI, one based for Sysmon execution, one more based for the security logs itself, one based for the PowerShell, one based for Defender. So each one is gonna detect one type of behavior. So that's what we try to achieve in the logic.
Any other question from the room? We have plenty of time.
I was fast.
You were fast, so I was late on stage. Sorry for that. But I guess that everything was perfectly clear for everybody.
I hope so.
I hope so. Thank you again.
Thank you.